The Economy of Machinery and Manufactures by Charles Babbage 1832. Section II. Chapter 20. On the Division of Labor. 241. We have already mentioned what may, perhaps, appear paradoxical to some of our readers, that the division of labor can be applied with equal success to mental as to mechanical operations, and that it ensures in both the same economy of time. A short account of its practical application, in the most extensive series of calculations ever executed, will offer an interesting illustration of this fact, whilst at the same time it will afford an occasion for showing that the arrangements which ought to regulate the interior economy of a manufactory are founded on principles of deeper root than may have been supposed, and are capable of being usefully employed in preparing the road to some of the sublimest investigations of the human mind. 242. In the midst of that excitement which accompanied the Revolution of France and the succeeding wars, the ambition of the nation, unexhausted by its fatal passion for military renown, was at the same time directed to some of the nobler and more permanent triumphs which mark the era of a people's greatness, and which receive the applause of posterity long after their conquests have been wrested from them, or even when their existence as a nation may be told only by the page of history. Amongst their enterprises of science, the French government was desirous of producing a series of mathematical tables, to facilitate the application of the decimal system which they had so recently adopted. They directed, therefore, their mathematicians to construct such tables, on the most extensive scale. Their most distinguished philosophers, responding fully to the call of their country, invented new methods for this laborious task, and a work, completely answering the large demands of the government, was produced in a remarkably short period of time. Camproni, to whom the superintendence of this great undertaking was confided, in speaking of its commencement, observes, "J'aime de livre I avec taler de dont j'ai toys capable, yet je m'occupe I de bord du plan général de l'exécution. Toutes les conditions que je vois remplir nécessitoient l'emploi d'un grand nombre de calculateurs, yet il me vient de la pensée d'appliquer la connexion de ces tables la division du travail, dont les arts de commerce tirent un parti si avantage pour réunir de la connexion de main d'œuvre. L'économie de la dépense et du temps." The circumstance which gave rise to this singular application of the principle of the division on labor is so interesting, that no apology is necessary for introducing it from a small pamphlet printed at Paris a few years since, when a proposition was made by the English to the French government, that the two countries should print these tables at their joint expense. 243. The origin of the idea is related in the following extract. "C'est un chapitre d'un ouvrage anglais 1 * justement célèbre, accuse probablement de l'existence de l'ouvrage dont le gouvernement britannique veut faire junior le mont savant. Voici l'anecdote. M.D. Prony était engaged avec les comites de gouvernement. A composer pour la division centesimale du cercle, de tables logarithmiques et trigonometriques, qui, non seulement northeast les centrines de desire quant à l'exactitude, mais qui formassent les monuments de calcul 1 plus vaste et le plus imposant qui jamais est exécute, ou même conçu. Les logarithmes de nombres de 1 à 200.000 formating a ce travail un supplement nécessaire et exigeant. Il faut des M.D. Prony de s'assurer que même en association 3 ou 4 habiles coopérateurs. La plus grande durée presumable de vite northeast we suffirait pas pour remplir ses engagements. Il était occupé de cette fâcheuse pensée-lersk. Southeast trouvant devant la boutique d'un marchand de livres. Il apricot la belle édition anglaise de Smith, Donny Londres en 1776. Il ouvrit le livre au hasard. Et tombe sur le premier chapitre, qui traite de la division du travail, et de la fabrication de épingles et site pour exemple. A peine avait il parcouru les premières pages, Q, part, une auspicieuse inspiration. Il concut l'expedient de mettre ses logarithmes en manufacture comme les épingles. Il fait cet ainsi moment, à l'école polytechnique, de la consuder d'un parti d'analyse les genre de travail, la méthode de differences, et ses applications ou interpolation. Il valait passer quelques jours à la campagne. It revint à Paris avec les plans de fabrication, qui est suivi dans l'exécution. Il rassemble deux ateliers, qui faisaient d'autant séparément les mêmes calculs, at southeast Servient D verification reciproc. To asterisk 244. The ancient methods of computing tables were altogether inapplicable to such a proceeding. Camproni, therefore, wishing to avail himself of all the talent of his country in devising new methods, formed the first section of those who were to take part in this enterprise out of 5 or 6 of the most eminent mathematicians in France. First section. The duty of this first section was to investigate, amongst the various analytical expressions which could be found for the same function, that which was most readily adapted to simple numerical calculation by many individuals employed at the same time. This section had little or nothing to do with the actual numerical work. When its labors were concluded, the formulae on the use of which it had decided, were delivered to the second section. Second section. This section consisted of 7 or 8 persons of considerable acquaintance with mathematics, and their duty was to convert into numbers the formulae put into their hands by the first section, an operation of great labor, and then to deliver out these formulae to the members of the third section, and receive from them the finished calculations. The members of this second section had certain means of verifying the calculations without the necessity of repeating, or even of examining, the whole of the work done by the third section. Third section. The members of this section, whose number varied from 60 to 80, received certain numbers from the second section, and, using nothing more than simple addition and subtraction, they returned to that section the tables in a finished state. It is remarkable that 9/10 of this class had no knowledge of arithmetic beyond the 2 first rules which they were thus called upon to exercise, and that these persons were usually found more correct in their calculations, than those who possessed a more extensive knowledge of the subject. 245. When it is stated that the tables thus computed occupy 17 large folio volumes, some idea may perhaps be formed of the labor from that part executed by the third class, which may almost be termed mechanical, requiring the least knowledge and by far the greatest exertions. The first class were entirely exempt. Such labor can always be purchased at an easy rate. The duties of the second class, although requiring considerable skill in their arithmetical operations, were yet in some measure relieved by the higher interest naturally felt in those more difficult operations. The exertions of the first class are not likely to require, upon another occasion, so much skill and labor as they did upon the first attempt to introduce such a method, but when the completion of a calculating engine shall have produced a substitute for the whole of the third section of computers, the attention of analysts will naturally be directed to simplifying its application, by a new discussion of the methods of converting analytical formulae into numbers. 246. The proceeding of Camproni, in this celebrated system of calculation, much resembles that of the skillful person about to construct a cotton or silk mill, or any similar establishment. Having, by his own genius, or through the aid of his friends, found that some improved machinery may be successfully applied to his pursuit, he makes drawings of his plans of the machinery, and may himself be considered as constituting the first section. He next requires the assistance of operative engineers capable of executing the machinery he has designed, some of whom should understand the nature of the processes to be carried on, and these constitute his second section. When a sufficient number of machines have been made, a multitude of other persons, possessed of a lower degree of skill, must be employed in using them. These form the third section, but their work, and the just performance of the machines, must be still superintended by the second class. 247. As the possibility of performing arithmetical calculations by machinery may appear to non-mathematical readers to be rather too large a postulate, and as it is connected with the subject of the division of labor, I shall here endeavor, in a few lines, to give some slight perception of the manner in which this can be done, and thus to remove a small portion of the veil which covers that apparent mystery. 248. That nearly all tables of numbers which follow any law, however complicated, may be formed, to a greater or less extent, solely by the proper arrangement of the successive addition and subtraction of numbers befitting each table, is a general principle which can be demonstrated to those only who are well acquainted with mathematics, but the mind, even of the reader who is but very slightly acquainted with that science, will readily conceive that it is not impossible, by attending to the following example. The subjoined table is the beginning of one in very extensive use, which has been printed and reprinted very frequently in many countries, and is called the table of square numbers. Terms of table: a table B first difference, C second difference. 113-242-539-7 for 16-9-5-25-11-636-13-749. Any number in the table, column A, may be obtained by multiplying the number which expresses the distance of that term from the commencement of the table by itself. Thus, 25 is the fifth term from the beginning of the table, and 5 multiplied by itself, or by 5, is equal to 25. Let us now subtract each term of this table from the next succeeding term, and place the results in another column B, which may be called first difference column. If we again subtract each term of this first difference from the succeeding term, we find the result is always the number 2, column C, and that the same number will always recur in that column, which may be called the second difference, will appear to any person who takes the trouble to carry on the table a few terms further. Now when once this is admitted, it is quite clear that, provided the first term 1 of the table, the first term 3 of the first differences, and the first term 2 of the second or constant difference, are originally given, we can continue the table of square numbers to any extent, merely by addition, for the series of first differences may be formed by repeatedly adding the constant difference 2 to 3, the first number in column B, and we then have the series of numbers 3, 5, 6, etc., and again, by successively adding each of these to the first number 1 of the table, we produce the square numbers 249. Having thus, I hope, thrown some light upon the theoretical part of the question, I shall endeavor to show that the mechanical execution of such an engine, as would produce this series of numbers, is not so far removed from that of ordinary machinery as might be conceived. 3 * Let the reader imagine 3 clocks, placed on a table side by side, each having only one hand, and each having 1,000 divisions instead of 12 hours marked on the face, and every time a string is pulled, let them strike on a bell the numbers of the divisions to which their hands point. Let him further suppose that 2 of the clocks, for the sake of distinction called B and C, have some mechanism by which the clock C advances the hand of the clock B 1 division, for each stroke it makes upon its own bell, and let the clock B by a similar contrivance advance the hand of the clock the 1 division, for each stroke it makes on its own bell. With such an arrangement, having set the hand of the clock to the division I, that of B to II, and that of C to II, let the reader imagine the repeating parts of the clocks to be set in motion continually in the following order, viz. Pull the string of clock A, pull the string of clock B, pull the string of clock C. The table on the following page will then express the series of movements and their results. If now only those divisions struck or pointed at by the clock be attended to and written down, it will be found that they produce the series of the squares of the natural numbers. Such a series could, of course, be carried by this mechanism only so far as the numbers which can be expressed by 3 figures, but this may be sufficient to give some idea of the construction, and was, in fact, the point to which the first model of the calculating engine, now in progress, extended. 250. We have seen, then, that the effect of the division of labor, both in mechanical and in mental operations, is, that it enables us to purchase and apply to each process precisely that quantity of skill and knowledge which is required for it. We avoid employing any part of the time of a man who can get 8 or 10 shillings a day by his skill in tempering needles, in turning the wheel, which can be done for 6d. a day, and we equally avoid the loss arising from the employment of an accomplished mathematician in performing the lowest processes of arithmetic. 251. The division of labor cannot be successfully practiced unless there exists a great demand for its produce, and it requires a large capital to be employed in those arts in which it is used. In watchmaking it has been carried, perhaps, to the greatest extent. It was stated in evidence before a committee of the House of Commons, that there are 102 distinct branches of this art, to each of which a boy may be put apprentice, and that he only learns his master's department, and is unable, after his apprenticeship has expired, without subsequent instruction, to work at any other branch. The watch finisher, whose business is to put together the scattered parts, is the only one, out of the 102 persons, who can work in any other department than his own. 252. In one of the most difficult arts, that of mining, great improvements have resulted from the judicious distribution of the duties, and under the arrangements which have gradually been introduced, The whole system of the mine and its government is now placed under the control of the following officers. 1. The manager, who has the general knowledge of all that is to be done, and who may be assisted by one or more skillful persons. 2. Underground captains direct the proper mining operations, and govern the working miners. 3. The purser and bookkeeper manage the accounts. 4. The engineer directs the engines, and superintends the men who work them. 5. The chief pitman has charge of the pumps and the apparatus of the shafts. 6. The surface captain, with assistants, receives the ores raised, and directs the dressing department, the object of which is to render them marketable. 7. The head carpenter superintends many constructions. 8. The foreman of the smiths regulates the iron work and tools. 9. The materials man selects, purchases, receives and delivers all articles required. 10. The roper has charge of ropes and cordage of all sorts. Notes. 1. An Inquiry into the Nature and Causes of the Wealth of Nations, by Adam Smith. 2. Notes sur la publication, proposi par le gouvernement anglais des grands tables logarithmiques et trigonometriques d probabilium primaire df. December 1, 1829, page 7. 3. Since the publication of the second edition of this work, one portion of the engine which I have been constructing for some years past has been put together. It calculates, in 3 columns, the table with its first and second differences. Each column can be expressed as far as 5 figures, so that these 15 figures constitute about 1/9 part of the larger engine. The ease and precision with which it works leave no room to doubt its success in the more extended form. Besides tables of squares, cubes, and portions of logarithmic tables, it possesses the power of calculating certain series whose differences are not constant, and it has already tabulated parts of series formed from the following equations. The third differential of ux equals units figure of delta ux. The third differential of ux equals nearest whole number to 1/10,000 delta ux. The subjoined is one amongst the series which it has calculated. 03486 42970 to 04991 50530 to 16907 58813 14 9295 67826 70 12236 77602 230 15,741 88,202 495 19,861 99,627 916 24,597 111,928 1,504 30,010 125,116 2,340 36,131 139,272. The general term of this is ux equals xx1 x2/1 x2 x3 plus the whole number in x/10 plus 10 sigma circumflex accent 3 units figure of xx1/2.